Hi everybody. This is another intersection of two arrows algorithm from lead code, and I'm going to try to solve it. So, given an array, write a function to compute that intersection. So we have a first example here, and that intersection is 2, 2. So this is the expected output. 2, 2 from both arrays is that intersection. And from the second example, we have 4, 9, and 4, 9 right here, and 4, 9 right here. So for note, each element in the result should appear as many times as it shows in both arrays. The result can be in any order. Okay, sounds good. Right. What if a given array is already sorted? How would you optimize your algorithm? Good question. What if num's size is small compared to num's to size? Which algorithm is better? What if element of nums2 are stored on disk and the memory is limited such that you cannot load all elements into the memory at once? Okay, so from what I'm understanding, I think my best option would first be to figure out which one is the small array and which one is the big array. And so then I can loop through the small array and use the current element and find its index inside the big array. If it does exist, it's going to return his index. If it does not exist, it's going to return -1. So I can use an if statement and check to see if my index return value is not -1. So then I can push, those indexes inside my result array. So I'm going to create a result array and I'm going to initialize it with an empty array. And then I'm going to find the small array by checking num star length to nums to the length. If that's the case, I want to return nums1, and if not, I'm going to return nums2. So let's find the big array. So I can do it by checking if the small is equal to nums1. If that's the case, I want to return nums2. If not, I want to return nums1. Then I can loop through the small array and then let me create a index variable and set it equal to big, the big array in this case. Okay, let me just change my naming right here. Small array and big array. So then I can, this is more descriptive. So I do big array, the index of n. So now I can check to see if the index is not -1, which in this case proves we found an index. So I can just push by slicing from the big array. So then I can pass the index and pass this. And so I can just return the result array. So I think that should be it. Let's run the code and see. Okay. Oh, that's true. The naming issue just right there. So let's fix it. Let's run the code again. Now we got 222. Okay, let's submit the code and see what we got. Okay, looks like the code is being accepted. Let's see on the runtime of this code. Okay, it is among 59.48% of JavaScript submission, but sometimes the lead code runtime checking is not 100% accurate. So what I'm going to do, I'm going to run the code again. Because the time complexity of this algorithm right now is only ON. So let's check again and see what we got. Okay, now we're moving towards 80% of JavaScript submission. As I said, sometimes the lead code, runtime is not accurate. So thank you so much for watching this video, guys, and see you guys next time for another algorithm solving.